So welcome everyone. I came here with kind of weird type of use case how to use the Zephyr. I'm teaching the operating system theory at the Technical University in Liberec. And my original background is in the hardware and the digital signal processing. And 20 years ago, when I started to work in the industry, I was looking forward to write some pretty nice filters and stuff like this. But my first task was to write the operating system in assembler for some DSP chip. And I wish I would have known everything I know these days about the operating systems. So that's kind of logical that later on, when I started teaching, my first subject were the operating system theory. So when I teach, I always try to learn my students, the important principles. And just to explain, I need to give you a little bit background related to the course and to the teaching, because I will later on explain you the work we are doing there in Zephyr. So our students who have the operating system theory as a subject at university, they are typically at the second year of their study, and they are not so experienced in, let's say, in programming in general, neither in the C or C++. And this is the main reason why we have decided not to use as a role model the Linux kernel, because it's too complex for them. And because our field of study is kind of general informatics, not just the embedded systems, they have very limited hardware knowledge. So we need to learn them this stuff as well. And we have two big groups of students in our classes typically. Some of them have, let's say, some general high school. They are excellent in math, but they do nothing about the hardware. And the second group, they are coming from, let's say, industry high schools focused to the electronics development. So typically they are stuck in math and theory, but they are excellent in hardware. So we need to learn them something together in the groups. The teaching at Czech universities, the most important part is that the teaching is divided into, let's say, two parts. We have some so-called theoretical talks, and they are for the whole year. It's roughly 100 of students, and then we have the practical labs. And the only mandatory part of the teaching are the practical labs, so you can imagine how many of them are coming to the theoretical lectures. But still, we can deal with that somehow. We have roughly about 14 lessons per semester. So we need an operating system to play with, because we are explaining them a lot of theory, and I want them to use the real operating system and to learn how those principles are applied in some very real use case. So again, Linux is too complex for them. They are like those kitties, knowing nearly nothing. So you cannot phase them to work with the 6 million lines of code. So I was always looking for some real-time operating system, and since 2016 I was kind of happily using the Embed, mostly because it has the integrated environment which you can use from the browser, so there is no need to install any additional software to get all the demos working. And we had some STM32 based boards, and we had a lot of fun with that. The problem is that Embed supports only the ARMs. The second problem is that all the examples and stuff we are using written by ST starts to be obsolete because they are not updating the examples there. And also they changed the development environment. And also it was some new stuff was appearing on the scene. So that's why I have decided to move those labs to Zephyr. Mostly, from my point of view, what I really like here is that Zephyr supports several architectures, and in one lab you can say, we've explained you that you have several layers, let's say, in the operating system, and you need to be portable to different platforms. So within one lab, we are booting in the QEMU the x86 platform, and then we are booting some ARM-based board, changing just one configuration option to demonstrate that it's working. The other stuff, why I really like working in Zephyr, is that you can emulate it in the QEMU, again, working with the real hardware. For especially our informatics students, it's sometimes kind of hard. What's also important that there is a lot of really nice, really perfectly described documentation and a big community of users. And plenty of libraries, and also some of my side intentions were to use the Linux are those device trees used in Zephyr, because later on in the 5th grade we have the embedded Linux courses and we can build on what they have learned in the 2nd year. So these are the motivations why we have decided last year to switch from Embed to Zephyr. So next school year we will start completely with Zephyr, and now we are developing those labs. And because we have students coming from Erasmus to Czech Republic, and we have to do all the descriptions in English, so that's why I've decided to keep it open, let's say as an open source for everyone who is interested in those labs. So it's available on GitLab. It's still kind of under progress because the hard deadline is in September. The conference was just a soft deadline from that point of view. The general architecture is that in that GIP you will see there are plenty of folders, and there is some general README explaining the structure of the project, and each lab has its separate folder. Again, explaining what's, let's say, the topic of the lab. The plan is also till the September to convert the theoretical talks to have some more, let's say, theoretical background in those READMEs. So it shall come. The task was to create, let's say, 10 labs. Each of them shall be planned for roughly 90 minutes. And we are switching, just now we are using we are testing it on the QEMU with the ARM, the M0 core and the RT core for demonstrating the user space, and the x86 cores to demonstrate that how far you can go with Zephyr, to how mature architectures you can use. And thanks to Hardwario sitting down there, we also have the Hardwario Chestel platform. And again, hopefully this will be the reference hardware we will use in the labs for our students. And the students from last year volunteered to do the beta testing to verify that everything is working properly for their younger colleagues. So we have a lot of work there. So this is the structure of, let's say, the theory. If you've studied the operating system theory, I guess that your course was exactly the same, because there is, from some point of view, if you want to start with the general theory, there is not so much to change, but still the content of those chapters is different and different year by year. But I want to just explain you what we are teaching, because when we discussed that, oh, you're using the Zephyr in teaching, so you definitely shall use, I don't know, some embedded stuff of programming like state machines or the idle modes or the interrupts, but this is not in our focus. We are focusing again to general principles, so we need to explain the features of the operating system in general. We need to provide to the students some hardware overview, because again, they hardly know that there is such kind of nice stuff like user mode or the kernel mode. We need to explain that we have microkernels and monolithic kernels and stuff like this. Then they learn about the processes, scheduling, memory management, and let's say till the end of the term. As you see, there is no networking, mostly because at our department we have guys who are much more experienced in networking than I am, so I keep it to their lessons mostly. And this is how the labs are related. So you will see in the Git, you will see those folders. So I try to explain how do I link it together. The problem is that at the beginning of training period, they know nothing. So if they do not understand the concept of the kernel, it's hard to do anything with the memory. So I will go deeper in those examples, trying to explain exactly what we are teaching this and what's the main focus on this lab. So, but you can see that the general structure. This is how it looks like in the GitLab. So again, the first one is pretty easy. You need to get it working on your computer. So this is the first lab. And there is, if you look to the sources, there is nearly nothing. Everything is in README. Download this part of software, download this part of software, and get it working somehow. So this works also on the Hardwario array. So we know that we can start in September, and it will probably work well. And as I measured it on my students, all this stuff is roughly for 60 to 90 minutes, depending on how fast they are downloading the stuff. The second lesson is dedicated to the configuration, because again, for young students, this is really absolutely confusing, that you have many levels of entrance. There are many options, you did something, your software behaves somehow, then you change something, you absolutely do not remember where it was, how you did get it working. They never seen, neither they see key config, they never seen make mostly, they never used stuff like this, so we need to spend some time there. So again, no rocket science. I guess that they are just switching the board in this lab, so compile for this lab and then for that lab and do it from the command line and do it using CMake and do it using whatever you want to do. So at the end, they shall now all the proper ways of configuration the software, demonstrated on the real examples, because again, if you will read this in the Zephyr online documentation, you see the examples, but I've tried to do it in one lab in this 60 minutes to really test everything, to see the result, to see how it's working, not to provide just the general description. I missed the kernel. I see when I was working. So in the kernel lab, we are just demonstrating that, again, the kernel lab is mostly focused on the key config. We are demonstrating how you can configure the proper, how it's done, that you can port the operating system from one architecture to another one, and how it's different if you switch on the MMU, if you switch off the MMU, and stuff like this. And the last part of that lab is also the demonstration of some kernel API. The problem is that we are doing it before explaining devices, before explaining the threads, before explaining everything. So finally, I ended up with timers, because this is the only stuff which is pretty easy. But again, to demonstrate how to include the sources and how to work with the operating system API, it's pretty nice. So they are writing some timers, just messaging, I'm the timers from this one and the other one. Then we go to threads. For the students, this is the first time in their life when they are spawning any thread anywhere. And I know from my colleagues who are teaching later on in later years that they need me to teach it properly, because in the higher applications in Java and in JavaScript and stuff like this, you need to be able to understand the thread concept. So we spend a lot of time there. They are spawning the threads. We are in these labs. We are demonstrating also the difference between the kernel space and user space, because it's nice to do it here. And we are playing a lot with priorities and explaining how to work. What does the stack mean, and what does all the other features of the threads are doing. So they are able to spawn a thread. So finally, we can go to the scheduling. This is, again, from, let's say, theoretical point of view. Zephyr is an excellent example, because you can just, in the key config, switch the scheduling. You can explain in the theory that there are several ways how to schedule the processes, and then you are going to key config, and like in the shopping center, you say, I want to have this, I want to have that, and let's just watch how it's behaving, how the tasks change the scheduling. So again, we are playing with those different the preemptive and non-preemptive scheduling, and explaining how it works, how your software is different, and stuff like this. So this is exactly the result of the soft deadline. So the work is done till the first lap in this part. And then again, the second most important part, which I am supposed to teach, are the mutexes, semaphores, and synchronization, because again, in the next years, they will need it quite often, and they need to understand the process. So for this, we have a lab which was really popular in Embed, because we had nice displays with full of colors, and the display serves as the parking lot. So you have 4 spots in your parking lot, and you spawn 10 threads, and those threads are cars. Each car has its unique color and different time of parking. So they are simulating in the real time how this is working, if they have a lot of cars at one spot, or if they are able to save the drivers' lives and stuff like this. So the only problem is that in Zephyr we have no displaying, so I need just to rethink the design of this lab to have the same fun as we had last. but I guess we will do it because the parking lot, you need a lot of mutexes to synchronize about those shared data structures, and then there is that semaphore, and using this, they really understand how it's working. So this is the next part. And then we need to talk a lot about memory. Because again, if our students have some experience, they are mostly experienced in the application level programming, maybe JavaScript, maybe some Python. So we need to go in detail to explain at least the data structures used to reserve the memory, but also to explain that in Zephyr, you have no memory protection. You really need to think about it a lot. Again, I select what I like in Zephyr, that you can define your heaps, but you can use the C-labs as well. So later on, when our students go deeply in the Linux in their 5th grade, they are ready. We are building a path. Again, that's the second reason why I've selected Zephyr. It's that's so close to Linux from a lot of reasons. So you can also demonstrate it later on in parallel. Say, okay, you have learned this. It's simpler in Zephyr because it's for microcontrollers, and on a big servers you can repeat what you have learned and it will stay similar, and you can reuse the principles. And also we need to explain the virtual memory because again, these days students have no clue how the memory is working. It's so low. If you are working in Python, it's so hidden, so they have absolutely no idea. So we need to spend some time here explaining stuff. And yeah, this is the last part because again, we are playing a lot with the file system. So we are explaining how it's working. And then I have prepared some demo which emulates the SD card, and they using the APIs to access the file system and to understand it. So in the theory, we say them, okay, there is that FAT, but mostly you will see the ext and the BTRFS and whatever FS. And in the lab, we are going back to the FAT because it's simple, it's easy, and it's easily understandable. So again, you can't learn someone how to implement file system or how to work with that if you will start with the BTRFS, for example. But FAT is the old, nice FAT file subsystem is really great. And the last one, so I'm really fast, so at the end of semester, we will play also with the POSIX, again, because we want to teach them POSIX, teach them how to, what does it mean? What does it mean if you are POSIX compatible? What does it mean that everybody says if you are POSIX compatible, porting of the applications is easy? So there is a lab which kind of demonstrates this. And the last one is related to devices. Again, as I said, I really want them to explain them because they need to understand the driver structures. They need to understand the hardware description and how can we separate the hardware description from the code. So we are explaining them the elementary device tree stuff and the elementary drivers. So they are writing their own silly driver, doing something, and later on again, in 2 years, they will write their own modules for Linux kernel, and they will be somehow ready to do it. And that's all. So this is how we use it. The Git is available for everyone. I'm really happy for any comments. Again, this is not, our intention is not to learn them how to use Zephyr in their embedded application. We are using Zephyr because it's nice, cool, modern operating system, and we want to demonstrate this elementary stuff for our students to have a code which is understandable, where they can somehow orient and understand how it's working, which is definitely really complicated. In 90 minutes, you cannot explain how to write the driver for Linux kernel, but you can do it for Zephyr. It's kind of easier. So that's all. I'm open to any questions, comments.
Yeah, It's less a question, I think, and just more a celebration. But it's also true, and your students should probably know that those of us who sit here and work on Zephyr learned about OS theory from working on Zephyr 2, whether we admit it or not.
Yeah.
No, this is very cool. I love this.
Yeah, and generally speaking, I think that they show now that the operating systems are not just the iOS, Windows, and Linux, that the world is full of really nice systems. And I guess with a higher probability in their praxis, they will meet all the others. So I don't want to hide it from their eyes. Yeah. Okay.
More of a comment that I wish I had for operating systems.
You can come. The public lectures are open for public in Czech. Everyone can come. Okay, so let's have coffee. Thank you very much.